Good morning, guys. In this video, we will go over the machines. And remember, the main difference between frames and machines is that in the machine, I have at least one moving part. So let's take the first example on machines. Okay, so guys, this is a very simplified example on machines. Why is it a machine? Because it has pulleys. And I want to remind you guys that in pulleys, if I have a continuous rope, like this rope right here, so of course it will encounter the same tension, right? So if I have a continuous rope, I will have the same tension. Let's take a look on this machine right here. I know that the weight that this machine is handling is 600 newtons, and the objective is to find P as well as the reaction at C. Now, how to do this? It is, of course, by taking the free body diagram and applying the equilibrium equations. Now here, guys, I want you to recognize the continuous rope. So if you take a look, guys, this is the rope, all right? So it is going all over the machine, which means, guys, that all the ropes have the same tension, which is P, that is unknown, and I need to find it. Now, in order to start, I will take my free body diagram, the first free body diagram, as the pulley at A. So I will take this as my first free body diagram. And then, guys, let's put all the forces, all the external forces now, because this will be my free body diagram, then all other forces will be external, and these forces are basically this force right here, and this rope, this force right here, and this rope, and this force right here, this rope. And as you can see, guys, since all this rope is continuous, then they are all equal to P, alright? This means basically that P is equal to what? P is equal to 600 over 3, which is 200 Newton. So from this free body diagram, I can predict P. Now let's continue. If I take, guys, this free body diagram at B, what do I have here? So if I take this free body diagram here, of course, guys, this is the same rope, then I will have the same P. Of course, opposite to the first P and the pulley A, so that they will be cancelled out if I join them. And then here, what do I have? Here, the reaction in the member BC, that is holding this pulley at B, will be what? Will be, of course, 2P. So it is 2P. Now, if I take the pulley at C, so what do I have here? Basically, at this pulley here, so let's put it here, I have this reaction here in the member BC, and since this is 2P, then this should be also 2P but opposite. I have a P here. I have a reaction here, R. So I can find them by doing the sum of phi, very easy. So basically this R here should be equal to 3P. 3P and 1P is equal to 200, which means, sorry, I forget this P here. So don't forget this P at C. So basically it is 4P and 1P is 200, then the reaction at C will be equal to 800 Newton. So this is, guys, how I can solve this vertical pulley example, very easy. But guys, I want you to know that I can have other cases like the case that we'll be discussing later, where at this pin of the pulley, I can have two reactions in Y and in X. But here, guys, since I don't have any X force, then all the reactions at this pin will be equal to 0. And in fact, the member BC this member here is a two-force member. That's why the forces should be axial. Alright, so there's no x. Basically, in this example, it is very clear that all my forces will be vertical and that at the pin of this pulley, I only have one reaction. Now let's move to more complicated example. Okay, so guys, in this problem right here, I have a pulley supported by the separate here without an A. I have a member BC supported by the separate here, and I have also a separate at A. So basically I have two reactions at A, two reactions at C, and I have this weight right here. The question is to determine the horizontal and vertical components of reaction and at A and the force at C. So guys, basically I can predict that BC is a two-force member because there is no forces on this member. All the forces are on the joints. Alright, so on B and C, which means, guys, that since this is a two-force member, I will only have axial force. What does this mean? I will only have forces in the direction of BC, which means, guys, that the reaction at C will be in the direction of plus or minus x because BC is in the direction of x. And that's why, guys, in the question, as you can see, they are asking me to find the vertical and horizontal components at A. So I have two components here. Why? The force at C, they are asking me to find one force at C because, in fact, BC is a two-force member. Now, AD is not a two-force member because, as you can see, at this point B, I have a force on this member AD. So basically, this is not a two-force member, which means I will have two reactions at A. So let's solve it. Okay, so let's solve this. First of all, guys, I'm gonna choose an appropriate free body diagram that allows me to find directly my unknowns without wasting time. So of course, guys, you can go check the solution in the slides, but I will do now an easier method that can allow me to find all these reactions in a very easy way. I will choose this free body diagram, including this pulley. So in fact, guys, if I choose this free body diagram, what are the forces exerted on it? I have the weight, which is given 50 kilograms, so around 490 Newton. I have this force here, and since I have the same rope, then this force will be also equal to 490 newtons. So guys, I should make sure that this is the correct direction here, right? Because in fact, this rope here is pulling this free body diagram that I have chosen to the left, okay? And I have the separate, so let's put them in other colors. Assume that this is Tx, of course I can have another direction depending on the sign. And this is Ax and this is Ay. So basically, guys, these are the external forces. And now here, guys, I only have three unknowns. So I can basically find all my forces. How? I can take, guys, the sum of moments around A to get rid from the reactions at A. So what should be the sum of moments? Basically, I have this weight here. So what is the distance from the weight to the point A? It is 1.2 plus this 0.1, which is the radius of the pulley. So don't forget the 0.1. So basically it is 490 times 1.2 plus 0.1. And this weight is doing a clockwise direction. So I will assume that the clockwise is negative and that the counterclockwise is positive. And then I have plus Cx. It is also doing a clockwise rotation times the distance from the point C to the point A, which is 0.6. And finally, I have minus 490, which is this force. It is doing a counterclockwise times 0.6. 9. So that's it, guys. The sum of moments should be equal to 0, so I can basically find, of course, Cx. So now, guys, I know Cx. I can find Ax and Ay. How? By simply doing the sum of Fx equal to 0. So this will give me what? I have Ax plus Cx that I have already found it. Minus 490 is equal to 0. And then I can do the sum of Fy is equal to 0. And then I can find Ay, because in fact I only have two vertical forces. Ay should be equal to 490. So this is how I can solve this problem in a very easy way. You only have to choose your correct free body diagram. And then, guys, if the question is to find, so this is the answer of the question, but if the question is also to find the reactions at the pin D, don't forget, guys, that here I will have two reactions because I have two forces. Alright, so I should take this pulley is my free body diagram, and then, guys, what I'm gonna do is to do the sum of fx, sum of fy, and basically, of course, this will be equal to this force 490 and this will be equal to this force 490. Alright, so the machines, guys, are very easy to solve. You should only choose your free body diagram, apply the three equations of equilibrium if needed. You can only apply two equations of equilibrium like we did at the pulley at D, and then you can find all your unknowns. Thank you.